Hey friends, and welcome. And in this video we will continue from where we had ended off. In the previous video we had looked at mathematics 2020 GCE paper 2 for grade 12s, and this is simply a continuation of that video. So in this video we'll look at questions 4 and we'll see how we'll progress from there. So in the previous video we looked at question 1 to question number 3, so we can continue from question 4. So let us look at question 4. So here's our question 4. Question 4 says the program below is given in the form of a pseudocode. We've got start, we've got enter radius, we've got if radius is less than 0, then display error message and re-enter positive radius, else enter slant height. If slant height is less than 0, then display error message and re-enter positive slant height, else area equals pi multiplied by r plus slant height, and if display area stop. So we have a pseudocode and we are asked to draw the corresponding flowchart for this information given here. So you should be familiar with flowcharts, should be familiar with writing pseudocodes. And so let us see how we can work on this question together. So we have start. So whenever you're dealing with start, you should remember to say start and stop are symbolized by such shapes. You can call them ellipse or an ellipse or oval. I don't know what you'd call it, but we've got something like that. So we've got, don't know, I've written stop. We're supposed to have start at the beginning, so we have start. In fact, let's do this. So we'll have start, and we'll be using red for the drawings. We've got start. Then what follows after the start? What do we have? According to the pseudocode, we have enter radius. So whenever you have an input or an output, we use such a shape. Let me just show it here for you. So from start, we have to enter the radius. So we will write enter radius. Is it just radius or radius r? So enter radius. Okay, so just enter radius. And whenever you have an input or an output, you have such a shape. Okay, so this is an input. It is showing to say this is an input. You're inputting something, you're putting in something. And what follows after that? According to the pseudocode, if radius is less than 0. So how do we write that? So we have the next part, and we'll have radius. Okay, so let's write it here, radius less than 0. And what shape will we have? We'll have a shape that looks something like this. We have something like that, radius less than 0. And what follows after that? We have, so this is an it's an if or else statement, so it's a condition. And so if radius is less than 0, so then display error message and re-enter positive radius. So we'll have this part will be saying yes. So we're going to say yes. If radius less than 0, yes. And on this part we're going to have, what did we have there? We had display error message and re-enter positive radius. So we're going to have error message, error, enter positive radius. So this is an output. It's going to display this message on your screen. So this has to be in a similar shape as this one. So we're going to have a shape of this kind. Pardon my ugly drawings. So I have something like this. Okay. And this should lead you back to enter radius. So you enter a radius. If radius is less than 0, you'd have, if your radius is less than 0, it will say error, enter positive radius. It will take you back to radius. But if your radius is not less than 0, so say no, we are supposed to use white, and we will say no. If your radius is not less than 0, what happens? Enter slant height. So say enter slant height. And since you're putting in something, this is an input, so it will have this type of a shape symbolizing input or output. Enter slant height. Then what follows after entering the slant height is, if slant height is less than 0, then display error message and re-enter positive slant height. So we're going to have the same things that we have down there. So we're going to have slant height. Let's write it in white. Slant height less than 0, and would have the same shape as we did there, which is something like that. So I'm trying to minimize on the space. So okay, so what you should have in mind is this and this are the same. It's simply such a shape. Okay, so I hope you can see it. And if slant height is less than 0, we're going to say yes, as we did there. We'll have a yes, and we'll say error, enter positive slant height. And this will be enclosed in a similar shape as the one we have on top. We have that, and it should take you back to the enter slant height. But if slant height is not less than 0, so we will say no. Then what follows? What follows is else area equals that, and so we'll have we are going to have, so since this is a process, is an action that is taking place, it is denoted by, or it is enclosed in a rectangle. So let's just look at that again. We're taught to say area equals pi r plus slant height. So we'll have area in white, we'll say area equals pi star r star r plus slant height. So as I said, this is something that is going to take place, so we have it in a rectangular box. And what follows from there? What follows from there is we end it and display the area and stop. So we'll have display area and stop. So displaying the area is an output. You're going to have an output of the area, so we need to use such a shape, and would have, okay, so we display area, so this is an arrow. I'm going to have area, and since it's output, we will have something like this. And since we've run out of space, the only thing that is remaining is a stop. So we'll write this stop on this side, but the stop is supposed to be down there. And stop is in a similar shape as the start. So there would have stop. And you are done with the flowchart with just these easy steps. And for this, I believe you would get the full marks on this question. We'll look at the next question. So here's question 4b. It says express 2 over x minus 1 minus 3 over 1 minus x as a single fraction in its simplest form. So this is equal to, what is our lowest, or maybe what is our lowest common denominator? Would have the product of these two. So in that case, we'll have 2 multiplied by 1 minus x minus 3 multiplied by x minus 1. And this is all over the product of these two, which is x minus 1 multiplied by 1 minus x, right? And we're going to have 2 minus 2x minus 3x plus 3 over x minus 1 multiplied by 1 minus x. And then this would give us 2 minus 3 gives us minus 1 minus 3x. Sorry, this made a mistake. 2 plus 3 gives us 5 minus 2x minus 3x gives us minus 5x. This is all over x minus 1 multiplied by 1 minus x, right? We can factorize the top part and we will have 5 1 minus x over x minus 1, 1 minus x. And from there we can see that this and this would go, and we would have equal to 5 over x minus 1. And that would be your final answer. And in this case, you have expressed that as a single fraction, and you have expressed it in its lowest form. We can move on to the next question. So here's our question number 6. So we haven't done question number 5, and we will do it in a different video, in a separate video, because it involves construction, and that requires extra attention that we should give it, and that it really deserves. So we'll look at it in a different video, in a separate video. So we've skipped question 5, don't forget that. We've gone on to question number 6. So question 6 is dealing with vectors, and question 6a is saying, in the diagram below, Q is the midpoint of OC, and OABP is a straight line with line OA equal to AB equal to BP. OA is vector OA equals 2P, and vector OQ equals Q. So Q is the midpoint of OC. Apan pakat, this is a midpoint. And OABP is a straight line with OA being equal to AB with being equal to BP. And OA is equal to 2P. So if this is 2P, it means this is 2P as well. It means this is 2P as well. And this is 2P as well. OQ is equal to Q. So if this is the midpoint, it means this is also Q. Now we can move on to answering the questions. So the first question is saying, express in terms of P and Q or B. So where is B? Where is O? So from O to B, we'll simply have OA. So let's say OB equals OA plus AB. So you first have to move from O to A and from A to B. What is our OA? Our OA is 2P. What is our AB? Our AB is also 2P. So therefore, OB equals 4P. You can write it there. So OB equals 4P. The next question is saying BC. So from B to C. So you move from B. So BC, vector BC equals, for you to move from B to C, you have to move from B to A, and from A to O, then from O to Q, and from Q to C. So in short, we're simply saying from B to O, right? Plus from O to C. And you would have moved from B to C. So what is our BO? BO is, we found OB to be 4P, so meaning BO is negative 4P plus, what is our OC? Our OQ is Q, our QC is Q, so our OC is 2Q. So therefore we've expressed BC in terms of P and Q. So you can write it there, and this is giving us negative 4P plus 2Q. The next question is asking us to find vector AQ from A, with A, to Q. So we'll simply move from A to O. So AQ equals from A to O, so AO plus from O to Q, which is OQ. So AQ is equal to, AO is negative 2P. Since it's going in the opposite direction, would have negative. So negative 2P plus OQ, which is Q, plus Q. and that is AQ. So AQ equals negative 2p plus Q. And the last question is saying from C to P. Where is C? C is there, so we'll move from C to O and O to P. So CP, vector CP equals CO plus OP. What is our CO? Our CO, we found CO is simply negative 2Q because there are two Q's there. So you move from C to O, then O, from C to Q, then Q to O. So we have CO being equal to negative 2Q plus OP. OP is being equal to, is equal to 2P plus 3P plus 2P plus 2P, which gives us 2, 4, 6. So plus 6P. And that is your answer on that question. So let's just write it there. We'll have equal to minus 2Q plus 6P. And we're done with question 6A. We can move on to question 6B. Here's our question 6B. It says the gradient of a curve is, so gradient, we're supposed to be using black. We're not supposed to be using black, we're supposed to be using white. So the gradient of the curve is equal to 3x plus 2. We're asked to find the equation of the curve if it passes through the points 0, 2. 0, 2. So we know that gradient is simply equal to the y, the difference in y over the difference in x. So we can simply say dy dx equal to 3x plus 2, right? And to find the initial expression that we had, we'd have to integrate this. So if we integrate this part, we're going to have this is equal to 3x squared over 2 plus 2x. But then we've been told to say, or plus c. We've been told to say it passes through the points 0, 2. So this is y equals to that. So 0, 2, this is our x, and this is our y. So where there's y, we'll have to replace it with a 2. And 3, where there's x, we'll have 0 squared over 2 plus 2, 0 plus c. So therefore, the value of c is c equals 2. So our equation would therefore be y equals 3x squared over 2 plus 2x plus c. And that is how we work around question number 6, A and B. I think we can end here for today, or for now. In the next video, we'll continue and see how far we can go. So thank you very much for watching, and remember to subscribe.